Hi, and welcome to another episode of the Ionic Viper series called nanoCHATs, in which we do one of the best, I think, critically reflective teaching practices, which is talking to each other as faculty members about our teaching. So I'm Shirley Lynn, and I'm from the Naval Academy, and I'm going to let everyone else introduce themselves.
Hi, my name is Tasneem Siddiquee. I'm from Tennessee State University. I teach inorganic chemistry as well. And I'm going to let next person introduce.
Hello, my name is Darkus Jenkins, and I am an associate professor at Savannah State University, where I teach principles of chemistry, organic and inorganic chemistry.
Hi, my name is Jingjing Qiu. I'm from San Francisco State University, and I teach inorganic chemistry lecture and lab this semester.
I'm Taylor Haines. I'm from Cal Poly San Luis Obispo. I teach our inorganic chemistry lecture and lab. I teach a good bit of Gen Chem and our survey of organic class.
Welcome, everyone. So today our conversation will be about sharing an innovative method that each of our participants has used to promote academic honesty. So who would like to go first?
Can I go first? Because mine is not really method. What I have thought for a long time, I have seen that I would feel the same way as most of my colleagues do. And because when someone cheats, then I would feel mad, be cheated. And then I asked this question that anybody, for example, whoever says something, or tells a lie or cheats or does something not honest, let's put it that way, in front of me. But when they will go in front of you, they probably, or there would be at least someone somewhere, they would be honest. So we are born honest. And then actually we try to remain honest all our life, wherever possible. So wherever there is a risk of losing something, I think we become, our honesty goes away. So my point is, if there was nothing to lose in academia, then nobody would be fearful and they wouldn't have to cheat. And if we wanted to promote that, maybe there need to be a win factor of some kind. So I thought about it and sort of tried incorporating in my teaching. This semester, I'm not teaching inorganic chemistry. So what the idea is, don't worry. The assessments are to test if you are doing okay, what have you mastered, and what have you not. That way we have a limited goal to work on. So once we know, and you are not going to lose anything, we'll make sure as a teacher, I will make sure that you understand all of those before we finish the semester. That's going to be my goal. So that's taking away the losing factor. And winning factor is that teacher committing to help the student succeed, hand holding. So that kind of environment would be ideal. I think it is inclusive. It is probably necessary too. Thank you.
Thank you. I was wondering, Tasneem, if you had looked into something called standards-based grading. And we actually have a slither on our YouTube channel about this from another member of the Ionic community. Is that something you've thought about?
I have not seen that. So I definitely would like to explore that. Yes, I will. You want to add or kind of like give an excerpt so that people who are going to be watching this, they will have also, they'll find an interest to explore.
Yeah, so standards-based grading, it's also called mastery-based grading. And essentially, instead of grading like you got 100 points on this assessment, It's more focused on like, you showed me on this assessment that you could achieve learning goals 1, 2, and 7. So that means that next time, hopefully you can get 3, 4, 5, and 6 from this set, right? And there's multiple ways you can kind of achieve those goals, but it moves away from like the point, like moving away from like, you got an 80% on this exam to you showed me you understood these concepts out of the full list. It has a bunch of different names. So there's like specs-based grading, standards-based grading, mastery-based grading, but they all kind of fall into that same kind of umbrella.
Thank you.
All right, who would like to go next?
Well, that was really great. And that sort of leads into what I've been doing while I've been at Savannah State. So one of the things that I noticed once I first got there is that students were more interested in achieving a score or a letter grade, as opposed to actually learning the information, making sure that we meet our outcomes for the course. So the following year, I went in and I tried to do something where I would say, students, you all don't have to worry about a grade. Let's just do what you need to do, which is show me that you are meeting our goals and standards and our outcomes are coming out of the class that we have already put in place for a specific course. So I would let them take exams and then they would be able to come back and do test corrections where they would still be able to earn points. So they're getting closer and closer and closer to earning a certain score. Well, most recently with everything that I'm learning about, all of the test banks that are out there that we are offered, or, students have a really interesting way of posting our exams online, and then later you find your question and answer within days of you giving that exam, and you're just like, wow, that was really fast. But it just made me take away points for an examination. So you just take the exam, just show me what you know, and then we'll go back, look at it, and then we'll try and see where you are deficient so that you can actually earn points by showing me you know something and you just needed a little guidance to get to where you are. So I'm seeing from last semester that students are now not interested in just getting a question answered correctly. They're actually trying to learn. So that pulls some of the dishonesty out of, I'll go to the internet and find the question. I'll go and see if I can get some help from a paid source and then give her the answer so that I reach my goal, which is to get out of the class with a passing grade. So that's one of the things that I'm doing with trying to, promote academic honesty.
So that sounds really interesting. So how have students kind of responded to that, right? So this kind of shift from, they spend 18 years of like point, and they get to your class. Do they feel like super uncomfortable with that?
Extremely uncomfortable. First, they think that I'm deceiving them, like, oh, she's just saying that so that we won't, and I'm like, no, really, no points. This has 0 points. You will get nothing if you answer correct or incorrect. I just want to know that while I'm standing up here, lecturing, offering as much assistance as I possibly can, that you're receiving it. You're hearing it, you're comprehending, and you're able to show me that you know exactly what you're doing. Because, we take a standardized test at the end of the semester, and if you don't have the information, you're able to show that you have mastered a certain number of those questions, then you won't be able to move forward in the sequence of classes. So I feel like when they first get there, they show a little hesitance with working with me, but then by the end of the semester, I see that we are going into a building relationship where I'm more so helping them, and they feel more confident in themselves, so that they're able to show and actually perform as I need them to. But that was it. I as soon as they come in, they're just like, wait, what do you mean I don't get any points for my exam? I've gone through my entire life where if I don't get a score, I don't get to move forward. I'm not interested in numbers. I'm more interested in outcomes. Did you do or did I do what I was supposed to do, which is help you grasp these 3 concepts? So it's been pretty interesting so far, and I can't wait to see what happens at the end of this semester with my students. It's been pretty great.
So Darkus, you had mentioned that you teach general chemistry all the way to organic and inorganic. Do you ever have returning students who had that method before with you, and then in a subsequent semester, do they get more comfortable and buy in more?
Yes. So the students that I had when I first started with just doing test corrections, those students come in and they're just like, oh, don't worry about cheating because you get to do test corrections. Like, she's going to give you points anyway for doing that. So just tell it, she just wants to know if you know something. And then from this past semester with no points in the examination, my Gen Chem 1 class that are in my Gen Chem 2 class now, they're just like, you all, it's the best feeling ever. Don't worry about it. She just wants to know if you can add, for example, 1 + 1. That's all I want to know is if you get it. And they are more willing to help each other. They have a group chat, and my TA is in the group chat with them, and she says that the conversations aren't about who has the answer to this. It's more, have you talked to her? Did she explain? Can we go talk to her today? It's been more of a let's help each other, let's really learn, as opposed to let's just get answers and move on. So I like it.
Wonderful. Jingjing, would you like to go next?
Yeah, to echo on what Darkus just mentioned, why students want to cheat? They want good grades. And what instructor want? We want students to learn. So I wonder, can we merge these 2 aspects? We motivate students to learn in which way they can earn good grades. So I would like to share a few examples I collected over the first half of the semester. So my great colleagues in CITO, the center in our university, shared the 4 bullet points that may help to achieve the goal. So I'm trying to follow the first one, foster intrinsic motivation, as well as lower the risk of the assessment. So students can focus more on learning instead of performance. And here is a few examples. I think it seems to be helpful. So at the very beginning of the semester, I tell students, oh, you will get points for all the in-class activity questions, and there is no right or wrong. It's more like open questions. For example, what is your goal for this entire semester? So they can set up some reasonable goal at the very beginning, and they can earn credit for that. And here are 2 examples. So some students focus more on specific stuff. Some students focus more on like the big goals. I like that. And another one I would like to do is ask a student to reflect and to summarize and connect what they have learned into the knowledge map, what people usually say. So I divide my material into 3 phases. For example, my phase 1 is on electronic structure of atoms and symmetry. And this is something they see on their online page. And I provide the study guide with different bullet points of learning objectives, so they can summarize their own reflection and summary in their own creative way. They will earn credit for that. And they are not judged by right or wrong. They are judged by like, did you do this job in a systematic way, in a serious way? So I want to share one example that my student presented. I really think it's good for students to summarize what they have learned, like atomic orbitals, the periodic trend, and the Slater's role, electronic shielding, and some of the symmetry elements. So it really fosters students to review and summarize before the exam. And because our exam is open book, so they can bring whatever they want to that, and this serve as a good guide for them. And one last thing I tried is, instead of using the question like you can search online. How about you introduce some open questions? For example, I ask students to use an analogy to explain what is electron shielding. So in a closed book, I used to ask them the concept so they can just memorize from the textbook. But if they can explain in their own words, I think it's more helpful. It's not searching on the internet. They are trying to think of the explanation in their own way. So here are two really interesting and creative examples, like students talk about the concerts, how different distance from the center of the stage is similar to electron shielding, and the other one is regarding like Black Friday shopping. So how different crowded people shielded their way into the thing they are trying to purchase. So I think these are the things I'm trying to implement in order to foster their motivation, and this lower risk assessment help them to learn. So these are the practice I'm trying to experiment in this semester.
So when you have students who are getting the reflection assignments, how receptive are they to actually saying, do I know what I'm talking about? Or how creative can I be? And is she going to accept my creativity in explaining the concept?
Yeah, so because this is their first time to do reflection, they may feel lost. I actually provided two examples. So the first one is you can follow the topic in the learning objective and trying to create a knowledge map, do drawings to summarize all the concepts. That's the first approach one of the students did here. The other approach is if you are a more practice-based student, so you like real examples, you can go through every single bullet point of the learning objective and write down what examples we actually practice regarding that learning objective, either the in-class activity or the homework problem or the reading examples I assign in the Libre text. So that is more helpful for the student who really like to practice through, for example, calculation, exact problem practicing. So there are two styles that I provided as an example. And I see both cases. Personally, I prefer the first one. I think it's better for students to connect the knowledge together, but there are students who are used to the example practicing type of thing, and I cannot against that.
And I have one last question. Do you use like a rubric just to say, listen, I want you to include this idea, this idea, this idea, as opposed to like, I'm going to score you based on you having this idea, this idea, this idea?
Yeah, so this grading rubrics is more between like the number and the one you just mentioned before. So I only have 4 tiers. The first tier is excellent. So you actually showed me you did a systematic reflection of all the learning objective. The second tier is very good. So you included everything. And the third tier is good. The last tier is average to is the lowest score they will get, but still not very bad. For those students, you can obviously tell who didn't put time into that, who probably trying to drag a few sentences from here and there and screenshot my PowerPoints and put it into one PDF file. And you can easily tell the efforts and how systematically they think about through every single learning objective, the bullet points. So yeah, it's not a penalty, but still encourage them to go that route.
So I just had a comment because we're talking about academic honesty, dishonesty. So have you seen or suspected, or did it appear to you ever that students may just simply copy a thing? It cannot be overlapping. So if they're from the same class, right, the topics they work on, it may overlap. And have you seen or suspected or, close to that people may be collaborating and working on, maybe not putting the thought that needs to create the knowledge map, and or someone may be helping, or maybe they all are getting help from somewhere else? Or I guess, do you teach them to work with every project that they are working on. Because
Yeah.
if we don't teach, then they're gonna learn from somewhere or not learn. So get the job done.
Yeah, it's actually interesting for this kind of open question type or this assessment reflection type of assignment. I didn't see this kind of cheating behavior, but interestingly, I do have some practice type of question in my open book exam. For example, calculating the shielding constant for a 4F electron in a gold atom. In that case, I do see exact same wrong answer. So that might be an indication of cheating behavior, which I need to in private talk to the students. So it's kind of interesting to see the more standard type of question, it's easier to find the cheating type of behavior, and this open question, and you are not like penaltying students for doing right or wrong. They have more freedom to just create their own material. So I don't see like similar or exact same contents in this aspect of assignment.
So can I go as a follow-up?
Yeah.
So what's the motivation then? So for in my experiment, it's not an experiment, experience rather, I've seen that motivating factor is, well, if students would do things, if they get points out of it, if they can reach their goal of winning, then they would do that. Without assigning points, how do you motivate them?
Oh, they do get points here. So for exam, they got like 60% of points, and the other portion, like the reflection, participation, group projects activity, they got 30 to 40% points. They do get points for that, but the grading rubrics is not like the standard, oh, you are right or you are wrong. So they kind of have more freedom to explore the open-ended question. That's how I frame it. So they feel like, oh, this is not something you can find the correct answer online. For example, on Chat, if I subscribe the member for $15 a semester, and they can say, oh, if I do this in a serious manner, and I will get a higher grade. So they have more room and freedom to explore. So that's my motivation. And I'm still experimenting to see how it works. It seems to work for the majority of the people, but still a small percentage people who are not willing to put the efforts, or who are more used to, oh, can I just calculate the number and get a high score? And they are not still quite used to that. So I'm still experimenting, see how it works until the end of the semester.
Thank you so much. Taylor, would you like to share next?
Yeah, so mine's a little bit more of a practical, detail-oriented way of approaching some academic honesty issues. And this really started a couple years back. I was talking with one of my colleagues, Dave Ziegler, and we were really frustrated with students in our Gen Chem labs because they'd be working on problems and they would turn to someone next to them as they're doing practice problems and say like, oh, what was the answer to question 3? Or, in thermodynamics, like, did all the ice melt? And they would get their answer from their neighbor and they'd say, yes, it did. And then they'd move on, even if it was something that wasn't graded. And then when the time came to have a quiz or an exam, and they had a question that was very similar, right? Maybe it was ice and methanol, or who knows what it might have been. Afterwards, they had no idea how to approach that problem because they didn't actually get practice doing it. And so what I started exploring and what we tried to figure out was how we could give each student their own little version of this question. And so what we started using was essentially random numbers from Excel. So Excel has a function that generates a random number. We could dictate a range. And so then we could give students their own version of these practice problem sets, right? So instead of everyone having 3 grams of ice, everyone would have some number between 2 and 10 grams of ice, and who knows what the outcome would be. And immediately what was really interesting is as we walked around the room, we didn't hear students saying, hey, did all the ice melt? What we started hearing was students asking, hey, how do you figure out if the ice melted? Because they knew they could sit there and talk and they could find out that they didn't have the same problem, right? And so they had to figure out how to actually approach the problem instead of just how to get to the answer. And that was something that we really kind of were focused on, was thinking about how can we get students to think about the process and not the result, right? And I think that that ties in a lot with some of these other discussions about points and all that, because the points are an ending, right, to the problem. And like what Darkus was saying, you want to think about the process, not just the ending. And so this was kind of something we started to roll out, and I tried it for a few quizzes, which logistically was a lot more challenging. I had to, figure out how to use mail merge in Word, which is this old thing that what used to make envelopes, right? You could take an Excel sheet and print individualized envelopes, but I used it to make, quizzes. So each student had their own little version that had these numbers in them. And since we've rolled it out a little bit more widespread with some further things that are built on the back end to make it easier to run. But using these randomized numbers and ranges at least gave the students their own version of a problem. And just based on conversations, they seem much more engaged with thinking about how to approach it, as opposed to just thinking about what that final solution would be. And so this is something we've kind of shared with a number of our general chemistry faculty. That's really the main place we've rolled this out, because that has the most opportunity for like numerical answers, right? It's harder to do this for organic chemistry where, right, it's a little bit more visual and graphical. But it's been really interesting so far just to see the response. A lot of students don't like it. Because again, they just want that answer, right? They see the simplicity of asking their lab mate what the conclusion was. And so they kind of lean on that a little bit. But come quiz or exam time, they understand the problems a little bit more, or at the very least, they understand where they should have learned it, right? Like, oh, I remember now, this was in that other lab, because they have a little bit more recall because they had to think about how to approach the problem. As opposed to just the solution.
That's really interesting. I was curious if you noticed a difference between questions that lend themselves to algorithmic problem solving versus questions that are still calculations that don't. Something I've noticed with some of my Gen Chem students is that if it's a clear algorithm, they become very willing and focused on sharing the algorithm, but not necessarily the conceptual understanding. And I was curious if you saw something similar.
I think that they prefer the algorithmic method, but if you have a few of these in there, right, they aren't really sure how to get the algorithm to spit out the number if they don't know where their individual number plays in. So like one example involved, so again, going back to the ice example, right, for thermodynamics intro kind of standard Gen Chem question, students, when they had their individual answers and they saw that they had a mass that was given of ice, they had to figure out, well, how does that interplay with the problem, right? And so they'd have to figure out, well, what point do I use the mass? And at what point do I use the molecular weight of water, which is the same for everyone in the room? And so even if they have this algorithm, they still have to think about what each of those components is doing, at least on a very surfacey level, right? And this is, again, mainly focused on those problems that kind of have a discrete solution, and less on ones that are explanations, which is why, like, Jingjing, I love that idea of like an analogy, like this question that's like, bring yourself into this space and do something. I think it's really interesting to kind of play with, because that's the opposite of these algorithmic problems, but it is still super individualized. So I think that there's a lot of kind of balance in there and where you can apply it.
Well, I just want to thank all of our participants today. They are all Viper Fellows, and we thank the audience for listening to our video. And if you would like to ask any of them questions or have any discussions about innovative ways to promote academic honesty, please go to our Ionic Viper Discord channel, the Viper Pit. And we hope to see you at our next Viper nanoCHAT. Thanks so much.